One genome cost $95 million in 2001. By 2022, just $525.
Every year since 2001, the U.S. government's genome sequencing program has tracked exactly what it costs to produce one human genome at the centers it funds. The first few years were painfully slow. The Sanger chemistry that decoded the original Human Genome Project was accurate but expensive, and by 2007 the price had only fallen to about $7 million. Then, in 2008, everything changed. A new generation of machines, Illumina for 54 and Solid, arrived that could read millions of DNA fragments at once instead of one at a time. The price didn't just fall, it collapsed to under $350,000 within that single year. From there, the curve kept bending downward for over a decade, dipping under $1,000 and settling near $500.
Before there was a price per genome to track, there was the Human Genome Project itself. 13 years of work, from 1990 to 2003, and about $2.7 billion in U.S. federal funding, run by an international public consortium of centers across the U.S., the UK, Japan, Germany, France, and China, to sequence the first human genome ever assembled, base by base. That project built the machines, the chemistry, and the software that every year on this chart would ride downhill on. $95 million. That's what it cost in 2001 to produce one human-sized genome sequence, using that same Sanger chemistry, run almost exclusively at a handful of government-funded centers. No private lab, hospital, or company could afford it on its own. A single genome cost more than most people's homes, multiplied a few hundred times over. Sequencing was still a national-scale scientific project, requiring months of lab time, not something a doctor could order for a patient. In just 12 months, the price fell to $342,502, a bigger one-year drop than the previous 6 years produced combined. The reason was a hardware revolution. Instead of reading DNA one fragment at a time, new sequencers read millions of fragments simultaneously, in parallel. It's the same kind of leap computing made moving from a single processor core to many, except compressed into a single calendar year. Sequencing centers that had run one machine now ran rooms full of them. NHGRI's own tracking makes a striking comparison, measured against Moore's law, the rule that computer chip performance roughly doubles every 2 years. Genome sequencing costs had been falling at a comparable pace through 2007. Then, starting in 2008, they decisively outran it, falling far faster than computing power was improving. A biology problem started being solved at a rate that beat the industry that inspired the comparison in the first place, and it kept beating it for years afterward as more sequencing companies entered the market and competed on price. Line the eras up side by side, and one of them stands out. Between 2001 and 2007, the price fell about 13-fold over 6 years of steady improvement. Then, in the single year of 2008 alone, it fell almost 21-fold, a bigger drop than the 6 years before it managed together. After that, the pace kept accelerating. Over the next 11 years, the cost fell more than 560-fold, as sequencing machines kept getting faster, smaller, and cheaper to run. Back in October 2004, when a mammalian-sized genome still cost $5 to $10 million, NIH publicly set itself a target: the $1,000 genome within 10 years. It was an audacious goal at the time, a planned 4 orders of magnitude drop on a fixed deadline, with no guarantee the technology would cooperate. Reality landed close. By 2015, the price was just above that line, and according to this dataset, it decisively broke $1,000 in 2019, falling to $606, roughly 15 years after the goal was announced and 18 years after tracking began at $95 million. By 2022, the most recent year in this official series, one genome cost $524.62, roughly the price of a mid-range smartphone. It even ticked up slightly from the year before, a reminder that this curve isn't a straight line down. It's a series of technological leaps, plateaus, and the occasional small step backward, trending relentlessly cheaper over time as sequencing chemistry approaches the floor set by labor and lab overhead rather than the DNA reading itself. Put the two ends of this chart side by side, and the number is hard to believe: 181,585 times cheaper in 21 years. That collapse is why sequencing quietly became routine. Tumors get sequenced to match cancer treatments to specific mutations. Newborns get screened for rare genetic diseases. Pregnant patients get non-invasive prenatal tests. And a home ancestry kit processes a genome for less than a dinner out. In 2001, that same test would have cost more than most hospitals' entire annual budget. And per this series, the price still hasn't found its floor. One chart, one story every day. Follow for tomorrow's data story.